Good morning, everyone. This is Jim Chastain with EasyPower. Today's refresher session is on modeling techniques for setting up MCCs and EasyPower 1 lines. The refresher series is not meant to be an exhaustive study of any of the specific topics, but more of a focus on tips and tricks, if you will, or techniques, and comparing what the different options are so you can better understand the application of the tools for your systems. So welcome. Basically what we're considering is that a typical industrial electrical system layout will include many different elements, including switchboard, panel boards, and MCCs. And so this will be the focus of our study today, or our discussion today. And I'd like to kind of start with a poll, see what kind of systems you normally deal with, and if you would kind of take a couple minutes to look at this and see kind of what fits your situation. Now, as I indicated, the focus that we're kind of going for is to give you some insight as to the alternatives, and not so much describe one thing or another, one specific system or another. So as I think the common definition is, the motor control center is a collection of a particular set of components that control the motors. These can include starters, power factor correction capacitors, VFDs, even some PLCs or metering, and all that kind of falls under the general category of MCCs. Basically, most of the low voltage systems are in a 208 to 600 volt range. Medium voltage MCCs would be 2.3 to 15 kV. In EasyPower, there's basically two ways to kind of deal with this. One is what I consider to be the individual bus, where we draw out the MCC as a specific bus in the one line, and then we detail the loads from that, and yet we still consider the whole combination as a MCC device or unit. Secondarily, there's an MCC icon that lets us consolidate all this information inside of one element in the one line, and there's trade-offs involved, and that's basically where I'm focusing the next 30 or 40 minutes. When we handle the units as separate buses on the one line, we have the ability to open up that bus as it appears, and then define it. By default, my system is set up, I think, to draw an open air bus type, but you'll see as we get into the ability to divide or specify some other system, there are a host of different elements that could be described as. So what we're going to be talking about is the MCC. In this particular specification tab, we want to show more specifically what the rating is for that bus and what the bracing is, because these elements or these parameters are used in calculations for studies. We can also specify what kind of enclosure we're going to be using. From there, we can go to a description of that particular piece of switchgear and enable a spreadsheet, which will then let us invoke some load calculations or summing, and also give us the ability to do a schedule on the one line. To do this, to be able to utilize these features, we need to enable the switchgear spreadsheet and then indicate whether we're using kVA loads or amps. Then as we complete or get ready to go into Arc Flash study, we can designate how this particular system, MCC or bus, is handled, and the discussion becomes whether or not we utilize the global conventions for doing Arc Flash calculations, or if we isolate this particular system or do something special, and we'll talk a little bit about that, because that's another key feature actually for any bus, because all these elements apply to any bus that we put on the system. Then if we utilize a single icon as an MCC, probably the biggest difference is going to be, rather than 16 or 17 elements that could be in one of the online representations, we bring everything down to one bus. And if we're in a mode to try to minimize the number of buses we use in our system, this could be a significant advantage. But as we get into the designation for the icon, we have pretty much the same elements that need to be detailed because we need to make sure we're not exceeding the parameters or the ratings for the bus structure inside the MCC. As we go into describing the different parts of the MCC and the icon, the incoming main breaker or fuse is handled just like any other device or any other protective breaker, and it receives its own breaker data dialog box. And then as we get into a description, there are some tools very much like a wizard that do a lot of this construction for us as far as the spreadsheet, but now that it's in a spreadsheet form, we have some other abilities now then to cut and paste, change, and again keep all that information in one place and still have it count as one bus. The function of tabulating the loads or summarizing the loads is also built into the icon, and it gives us pretty much the same information as we had in the standalone buses. Here we're segregating the load and as far as the size of the motors that are involved, the different loads that have been detailed, and then also maybe what's being pulled in from downstream. And so if we haven't done this, this is, I think, not a critical step, but certainly a step that should be part of our setup procedure when we're using the icon. Finally, a critical step in that if you don't complete this particular step when you're using the icon, the tool will say, hey, you got something missing, and that is the short circuit calculation for summarizing or coming up with X over R values that will be used for arc flash short circuit studies. And that's these can be entered manually or calculated based upon the data that's been entered. So as I mentioned, by utilizing the icon, it gives us the ability to address some extra features that aren't available in the standalone. And we're going to touch on these as we get in farther into this refresher episode. But one of the features, and it depends upon how your business model goes, is the ability to use a pre-configured set of loads that we refer to as library load, and I'll show you where that's utilized in the system. Then under description, again, we have the ability to go in and detail, including the cables and the circuit breakers that are used for this particular bucket in the MCC, all of which is contained. And as you can see in this particular example, if we had this all spelled out on, it looks like it's maybe 30 some odd loads, we'd have at least 60 additional buses in our bus count. And if we have a large number of MCCs, then perhaps that would help us in terms of organizing our one line. So the thing I want to kind of point out as we're going through this comparison is what the trade-offs are. And probably the biggest trade-off or the biggest difference is that with the icon version of the description of the loads, we're not able to put labels, individual labels on the individual loads. And so as with panels, the labeling scheme is taken down to the main bus on the MCC, and consequently the loads would only make a difference in so far as their contribution to the total current, but we would not have an individual label on every load. Likewise, the details in the schedules that are provided, schedules are available on either methodology but the details are different, and we'll kind of compare that. Likewise, as soon as we define one of these individual buses as an MCC, it affects our ability to use the find function, because that bus is still considered a bus when we talk about the database browser. Again, we talked about the number of buses and the trade-offs involved there. The ability to do group loads is not that much different, and we'll show that. But there is the ability to use copy and paste and library loads when you're in a spreadsheet mode a little bit differently. So I have one more poll that I wanted to kind of get some feedback on before we jump into the specifics here. And that is, I'm curious how people, their methodology or scheme is in terms of the kind of labels that you put on an MCC. And if we actually have an application note that's called Do's and Don'ts of Labeling. And for those of you that have some questions or would like that kind of a feedback, I encourage you to either download that from the website or contact your sales person at EasyPower and ask for the Do's and Don'ts of labeling. All right, so I'm going to close this poll and show what we got here. So here's what the group is telling me. I appreciate the feedback. So based on that, we're going to jump into the tools and compare these two results, or two techniques. All right, it turns out in this particular one-line diagram, and in fact this is a system that's in the tools in the sample version, or the sample folder on any tool installation, and referred to as the biggie file. It gives us the ability to look at a specific bus that might be considered as an MCC, and then an MCC specifically. So now that I've set this up, let me kind of... So this bus originally was set up as an open air bus. By default, when I drew a bus on my one line, my default settings for the designation is open air. Well, that confers a certain connotation and specifics in terms of the air gap that's utilized during calculations. So let's say in this particular case I want to consider this an MCC, and to do that it's important for me to enter what I know to be the ratings for this particular unit that I'm using. And so I know that this particular manufacturer manufactures a bus that has a 1,000 amp bus rating for total current, and then it's braced for 45,000 amp surge, max fault. It's copper. I'm going to go ahead and change the name, and this is the part where as soon as I change it, as soon as I make this designation, even though I'm going to call this an MCC, when I utilize find, it's still going to be under a bus designation. We'll look at that shortly. Now you'll notice I've already set this up with all the individual loads and breakers. So all I'm doing with this convention is essentially gathering it all in one place and calling it an MCC. We're going to calculate the downstream load. I could show it in kVA or amps. So let's go ahead and do that. So this ends up being a nice feedback for the designer to make sure I'm not exceeding some of my design considerations. And if this were any other element besides an MCC, I would have the ability to display the elevation, but we're not going to get into that. So then the last thing in terms of what this particular icon consolidation of devices allows us to do is to designate, in fact this particular tab is available on any bus that we set up. What it allows us to do is to specify whether or not we're following the global conventions for doing the arc flash calculations, and or excluding this bus from consideration in terms of instant energy calculations, or if we want to force it to a specific value. For now, we're going to say calculate. Probably the biggest use of this particular function is if we have some buses that we want to include the main or exclude the main, you may want to have a convention within your shop that says, okay, by default, I'm going to have excluding main on my global, and then as I set up an individual MCC, I will include it because I know that this particular breaker is isolated. There's a barrier between a person working on this hot bus and the main breaker coming in. So that's probably a good convention in any case. All right, so for now I'm going to use this, leave it on global. We'll talk about these other functions in a future session of a refresher session. All right, so real quickly, now that I've got this designated as an MCC, what we'll go out and is we find, if we go to look for this particular bus on the one line, we'll see that it's still set up under bus. And so if I go to look for MCC, it will not be under my MCC listings. All right, so I don't have an MCC 10, but I do have under bus an MCC 10. Now, before we leave this, I can also, now that I've defined this as an MCC, I can insert the schedule now for that particular MCC panel. And this gives me the ability to at least put up some designated information, and frankly, these can be customized. And again, that's another function we'll cover in a future refresher session. Okay, so find and still, when I go to calculate the breakers, so let's go ahead and do my short circuit, fault the buses, arrange for arc flash. Okay, so what I'm trying to do here is point out that I will still get individual labels. If I had my breaker set up, I will produce individual labels for each of the downstream loads, which is the drawback in going to the icon methodology. All right, let me jump into the icon methodology. So again here, as we went to set up this particular bus, we described this as an MCC with a dedicated icon from the palette, the menu for the elements in the system. And as we set up this particular icon, again I'm working on MCC 10A, I have the ability to go through a series of tabs very similar to any other device, but now this gives me the ability to do the following. First of all, this is going to be a three-phase 4-wire. We have the manufacturer's name, we have entered the bus rating and the maximum interrupt rating. We've also given us some description and more details if we want to include them. When we go to the incoming tab, now this gives us the ability to designate specifically what the incoming connection is going to be. So it can either be main lug or it can be a breaker. We tell the tool specifically which cable we're coming in on, which again, I've kind of obscured the labels. C15 is the only one available. As we do incoming device, this is going to be treated exactly as any other incoming breaker. So let's go ahead and give it a generic. And by doing this, we'll be able to at least generate some instant energy calculations. Once I've created the part number, I go to the short circuit tab. If a number shows up when I click calculate, that means the tools have found this part number in the device library. It has an interrupt rating of 25,000 amps. And at that point, we go in and set up the main current trip point. and ground settings if they were available. All right, so now that we've got the main breaker designated, the next thing we do is go to the description. When we first set up a tool like this or an MCC like this, we will get a switchgear wizard element that comes up and asks us how many loads we have. So here we describe 21 loads as our maximum number, and so it sets up those number of buckets, and here at that point we're able to go in and designate what each one of those loads are. Our choices in terms of loads can be a standard motor, a standard load, which is a linear load, usually for heaters and lighting systems. We can have a VFD controlled, let me show that. A VFD controller, a sub panel, sub MCCs, a motor with a TCC in case we wanted to coordinate against it, a load with a TCC, a VFD controller with a TCC, and then lumped loads or grouped motor loads. Categories are set up for less than 50 horsepower and greater than 50 horsepower. Now as we do this, the tool then configures the rest of that row to accommodate the data that's required. Let me kind of pull this out a little bit. And so you'll see as I set this up as a motor, it now expects to see horsepower, and once we're given the horsepower, so let's say it's a 20 horsepower motor, it calculates full load current for us. It calculates based upon the typical settings for a motor of that size, the efficiency, the RPM, and the NEMA code. If we have specifics on the motor that we're using that are different from these numbers, we would enter it at this point. If we know the X over R value, we would enter that. If we don't know it and we want to use the typical values based upon these other parameters, because this is red, it's a mandatory data entry, but because it's bold highlighted at the top, we're able to do a calculate, and the tools then enter what the X over R value is for a 20 horsepower motor. So at the point we've got the motor specified, and the same is true for loads, except we gray out the motor entry and we tab over to the static loads. And so this next entry was a static, let's say a 1200 kilowatt, and it may or may not have kVAR entry. As we enter that data, then we're able to go in and then describe the data entry for each of the breakers. And as we tab over the conductors, and these are handled all exactly like any other cable in the system. So we would designate, by default we've set up THHN, we designate whatever we're using as our insulation, whatever conductor size is required for that size motor, the length, and then the conduit and the neutral size. For anything that's off system, in other words, a subsystem, a sub-MCC, or a sub-panel, we would, well, this actually has an implication in terms of auto design as well. If all the data that describes the load is within the MCC icon, then we can utilize auto design from within the MCC. If it's all outboard, which would be the case with a sub-panel or a sub-MCC, then the tool does not know, in terms of auto design, does not know what the details on this load is. And as I select sub-MCC, you notice it grayed out all this information. So as I get to the protective device, what I'm going to want to do is pull in the information that's downstream to be able to do my description on my protective device. Likewise with because the cables and the breaker for the sub panel will be outboard of all this information. All right, so what am I touching on here? We've described, all right, So a couple of the other things. The advantages of using this type of a display of an MCC. Let's go back to our load and not worry about the details. Because it's given to us in the form of a spreadsheet, we have several capabilities that we want to emphasize. First of all, let's say this bottom 6 rows we want to duplicate or copy and add to the panel or add to the MCC. I can do a highlight of all the elements, do a Control-C. I want to add one more row and do a Control-V, and now it handles that addition for me. So now we have these other 6 loads that were put in then after the fact. If I want to export this to Excel and manipulate it there, I can do so. I have to be a little careful. So you notice I selected the whole spreadsheet starting from one corner. Again, I'm going to do a Control-V. I can actually export it to a CSV file, or I can do the following. I did a Control-C to copy the elements. Let's go ahead and open up an Excel spreadsheet. Put this in there. And by doing this then, and for some reason I only got the bottom 9. So I kind of did a hiccup in my manipulation there of the one line. Let's start over. Oh. So what I'm going to want to do is change this first one from a motor to a load. So when I go out to my spreadsheet, start over. There we go. And now let's change this to a load. Now I have to be careful as I'm making entries in Excel, because if I don't match the format that the tool recognizes when it brings that information back, it's not going to be able to accept the data. So I make whatever changes I make in Excel, and then I go back, take a copy of this. There was some other note that I want to make here as we kind of get here. So I see where I made my error before. I overwrote the examples that I had. So I'm going to do a Control-C. Let's go back here. Now one thing that I noticed, and I'll come back to it in a second, is the fact that we have dates in the display, and I want to be able to go back to my Excel spreadsheet and talk about it. So as I kind of go through, so what you've just seen me do is essentially be a little bit careless in the way I was cutting and pasting, which is I think part of the reason to develop a technique and not fall into the trap of just blindly doing cutting and pasting, because you do have to follow the format in terms of the column structure and the data that gets entered. I do want to indicate here that there's a date in these column settings that reflects the last date of a change for that particular device, and utilizing that can be extremely valuable. Okay, so not to get sucked into the well of Excel, I want to make one other point here that's available for MCCs, and that is the ability to do library load. As I select a what's essentially a customized setup sheet that I've built. I'm going to designate that or connect that, and as I close the MCC and then reopen it, it makes it available to me to pick up under library load. So let's kind of go downstream. All right, to add here a load from the library, I've set up several different size of loads and pre-configured basically every element that needs to be entered. So let's say I'm going to enter a 40 horsepower motor. I would designate that as a sump pump. Here it's set it up as a motor, and I've already got my interrupting. My full load current hasn't been designated, so I calculate that. But because I selected this with the setup of the breaker manufacturer, I should be able to carry in all the settings that I pre-configured. This is done in the device library, and if I have a lot of MCC panels that I configure with a lot of typical loads, in this case I've got 100 amp heater, 100 amp motor, 100 horsepower motor, 200, 150, 40, they can be pre-configured with all the details that might support that particular type of load. All right, so let's kind of come out of this. As I make changes, as I mentioned before, I want to do a summary calculation and bring up any external loads in a sub-panel or sub-MCCs. And as the tool does this, it will do a comparison of my full load current with whatever was set up, both in terms of the bus rating and the incoming device. And as I go to close this, it'll say, hey, you've either got a problem or you don't. So apparently I didn't exceed anything. Likewise, I want to go to the short circuit and calculate, and based upon the changes I've made, it will recalculate the X over R ratings for that particular type of bus or type of system. Then likewise, if we have a reason for this particular MCC to be something other than the default settings for arc flash calculations, we have the ability to make those changes as we did in the standalone bus. Finally, when we go into arc flash incident energy calculation, as we produce the incident energy details, let's look at the current first. We can then go and produce the incident energy for individual buses, and then as we go to the arc flash hazard spreadsheet, the MCC now will only have one label versus the multiple labels that will be produced when we're looking at the individual standalone buses. All right, let's kind of see if I've got anything on track with what I was trying to accomplish. We didn't talk much about lumped loads. Let's go back and look at that. And we'll talk more about this in terms of motors down the road. But if we're looking at the loads in an MCC panel, if we were to pick out, let's say we wanted to lump, we had a bunch of small horsepower motors, less than 50 horsepower, we could lump them together in terms of what their contribution is, and at that point we would enter the total horsepower for that motor. let's say it was 200 horsepower. Let's say we had 10, 20 horsepower motors. And by doing this, we would have the ability to consider, again, a less complex example and accommodate the calculations for incident energy at the main bus level. So this is not only allowed but recommended in arc flash application of IEEE 1584. And again, it's another way to consolidate the amount of data you have to enter and still be able to utilize the impact of large amount of motor or inductive loads in the calculation of the incident energy on this particular bus. Again, these would not have individual labels, but they do impact the bus loading or the incident energy on the main bus for the MCC. Okay, so basically, if we're using an icon MCC, it dramatically reduces the bus count that's included in our one line. We're having fewer labels to deal with. We have the ability to do lump loads in terms of the motor sizing. We can incorporate the TCC curves if we want to coordinate against large loads in MCC. And we have a little bit more flexible schedule representation. As separate buses, we do have the ability to label each load. It's a little bit easier to figure out from just looking at the one line, although there's the ability to put schedules as well and summary. And it's easier to coordinate against several large loads rather than one or two in the spreadsheet. And then the copy and paste is frankly easier on the one line because we can, the tool set up to do that. All right, so that pretty much covers the details that I wanted to touch on. We'll deal with the questions in just a second. I'd like to refer you to a host of information on the EasyPower website, including the ability to download a demo version of the tools, over 3 dozen tutorials on various technical details utilizing the tools in different applications. And I'd encourage you to look forward to the regional training that we have, not only literally currently going right now in the Southeast, but we're starting to schedule regional training in different parts of the country for next year, all of which is on the EasyPower website.